Welcome everyone. Welcome to our channel Online TechTorials. Today we are going to discuss the topic eigenvalues of a matrix and characteristics equations. These are very important topic for matrix algebra. So let's start the corresponding topic. Obviously, question will arise, what is eigenvalues of a matrix? Well, the definition of eigenvalue, it is nothing but suppose there is a square matrix. Square matrix means obviously row and column of the matrix should be same. I consider the square matrix of order n. Okay, that means n number of row and n number of columns are there. Well, lambda, it is one of the real or complex number. It is called eigenvalues of the matrix A if there exists another vector x such that Ax equal to lambda x will satisfy. In that case, we consider lambda as a eigenvalue. So obviously question will arise how we can compute the corresponding eigenvalue of a matrix. Well, if we want to find out the eigenvalue of a matrix, initially we have to consider the characteristics equation. Okay, for any n by n system square matrix, first we consider determinant of a minus lambda I, that thing equal to 0. This particular equation is called characteristics equation. Okay, so question will arise, what is A? A is nothing but the corresponding matrix. Okay, obviously the elements will be like A11, A12, A13 and so on. Now this is your I. Suppose in this case I consider I3, that means third order identity matrix. So elements will be like 1 0 0 0 1 0 and 0 0 1. So if I consider determinant of A minus lambda I, we get the characteristic equation as this one. Look, if you subtract those two matrices, okay, then obviously the diagonal element will affect. If since I multiply lambda with the corresponding matrix I, so it will be lambda, lambda, lambda in these three diagonal positions. So if I subtract these two matrices, it will be like first element minus lambda. Similarly, diagonal element will be subtracted by lambda. So that is the corresponding characteristic equation. Since it is a determinant, so if we break it down, we can easily get one of the equation involving the lambda. So that is your characteristic equation of the corresponding system. Okay, now look, this is your corresponding characteristic equation. Well, if I split the corresponding determinant, then we get one equation in this form. Look, some constant into lambda cube plus other constant into lambda square plus c lambda plus another different constant k, that thing equal to 0. So if I break this system, we get this kind of equation. Okay, now obviously we have three different values of lambda. The values may be different, may be equal or may be complex, whatever, but ultimately we get three values. Suppose the values are p, q, r. So these particular values will be called eigenvalues. That means if any kind of eigenvalue problem is given, first consider the characteristic equation. After that, just expand the determinant, make it 0, solve it, you get the lambda values, and this lambda are eigenvalues. Okay, now question will arise, how many types of eigenvalues can be generated? Look, eigenvalues may be real, may be complex. Okay, in case of real, you can have equal eigenvalues, you can have zero eigenvalues and unequal eigenvalues, depends on the problem. So that is the basic computation purpose of our computation scheme of eigenvalues. Okay, now we are going to discuss one of the problem. Well, if you focus on this matrix, basically it is a 3 by 3 system, right? 3 cross 3 matrix, 3 row, 3 columns, and we need to find out the eigenvalues of the corresponding system. Look, we will consider the characteristic equation first. As I said earlier, that just observe the diagonal element 1, 5 and 1. Subtract lambda from the diagonal elements. Okay, consider that determinant equal to 0. Look, the rest of the portion like 1, 3, 1, this 1, 3, 1, these are same. No such effect on this other element. Okay, so if you break the corresponding determinant, obviously this is the first breaking, and if you solve it, you get the equation as lambda cube minus 7 lambda square plus 36 equal to 0. We all know how to break a determinant. So using the determinant break rule, you can obviously calculate or just simplify the corresponding equation. You get this kind of equation. Okay. Now we have three factors here. So if you apply your vanishing factor method for lambda cube minus 7 lambda square plus 36 equal to 0, obviously we have three factors of lambda. First factor is lambda plus 2, second factor lambda minus 6, third factor lambda minus 3 equal to 0. Okay, so if I consider the eigenvalues, obviously the eigenvalues will be lambda equal to minus 2 for this part, lambda equal to 6 for this part, and lambda equal to 3 for this part. So we have minus 2, 6, 3. Three different eigenvalues. Look, here the eigenvalues are real and also these are unequal. Okay, so this is the process whenever a matrix is given and just you calculate the eigenvalues. Okay, next we focus on another problem. Look, another matrix is given, another 3 by 3 system. Okay, so whenever we consider our characteristic equation, obviously the diagonal elements are 2, 3, 2 like this. So characteristics equation becomes 2 minus lambda, 3 minus lambda, 2 minus lambda here in place of diagonal, but the rest of the element 2, 1, 1, 1, 1, 2, these are basically same. So if I consider the determinant of this corresponding portion, make it 0, this is your required characteristics equation. Okay, so obviously next step is break. If you expand the determinant using our determinant expansion rule, we get this particular equation. Okay, so if I solve it or simplify it, basically we get 1 minus lambda into lambda square minus 6 lambda plus 5 equal to 0. Okay, so that is the corresponding simplification of this above equation. Okay, so in the next step, if you solve lambda square minus 6 lambda plus 5, you get two factors. First factor is lambda minus 1, another factor is lambda minus 5. So we have three different factors here. Okay, as I said earlier, that whenever you consider the eigenvalue, we have one of the equation involving lambda cube. So we have three factors. Here the eigenvalues will be 1, 1 and this is your 5. So we have the eigenvalues 1, 1, 5 in this case. Okay, we observe that the corresponding eigenvalues are real, but still these two eigenvalues are equal. It may happen. So that is the computation process of the corresponding eigenvalue problem. So if you get any kind of matrix using this rule, you can calculate the eigenvalues. Thanks for listening us. We will meet again with the new topic eigenvector of a matrix in the next video. So stay tuned with us. Thanks for listening.